Yes,
Okay,
madam.
okay. Thank you so much, sir, Gopalji, sir, and a warm welcome to everyone and to our today's speaker, Shri Dr. Burri Harsha Vardhan Reddy, sir. So, everyone, first of all, I would like to introduce you all with the Science Dialogue series, which is being initiated with the single motto to deliver or to impart the knowledge to the participants or to the students, faculties from the diverse background of the biological sciences or any other interdisciplinary sciences. So we have conducted more than 150 lectures in this science dialogue series, and today again we are here to have one more wonderful speaker of the today's session, Reddy sir. So if I have to introduce, now I am going to introduce everyone to the Reddy sir. So Dr. Reddy, he has a experience of more than 17 years. So if I talk about his scholarly things, so he has completed his graduation from Osmania University. Later on he moved to Sweden, from where he has done his PG followed by his PhD at Denmark. Right now, uh, Reddy sir, he is working as manager in computer vision group at artificial intelligence global company Al Khobar, Saudi Arabia. He has been awarded doctorate from the Aalborg University, Denmark, as I mentioned you earlier. He is an experienced computer vision consultant with more than 17 years of experience in data analysis, building data science models, machine learning algorithms, robotics, and advanced artificial intelligence uh, applications, which includes computer vision, natural language processing, and generative AI application. Since right now we are continuously listening the word artificial intelligence, so our sciences, our biological sciences, are also not being left out from this current kind of uh, invention or latest, you can say the latest incorporation in the field of science, that is artificial intelligence. So here we are again to discuss this topic with the guidance of Reddy sir, as the title mentioned, artificial intelligence for disease detection, classification, and predictive analytics. So along with our all participants, we are also looking forward to have this wonderful session with the Dr. Reddy. So, sir, we welcome you on this platform, and I'm going to hand over this platform right now to you to take over this, and you can please start your expert talk for this lecture.
Okay, so thank you, Madam Poonam, Madam, and Gopal sir. So it's been great for me here to start. This is my first time on this platform. I'm happy to interact with you all. There are like approximately 30 participants here. I'm really very happy for this interaction, and I also appreciate Gopal sir as well as the Poonam Madam for their initiatives to democratize the technology to all the people. So this is the very nice initiative, sir. Hearty congratulations for this initiative, and
Thank you for accepting our invitation and joining,
no,
sir.
that is honored, sir. That is really it's a great opportunity for me also to interact many people here. Okay, uh, so instead of introducing one more time myself, okay, directly I'm jumping into the topic. So let me share my screen here, and hope you're seeing my screen, or maybe otherwise let me know. Uh, just a minute. Okay, you're seeing my screen. Yes, all. Can anyone confirm
Yes,
it? Yeah.
yes, yes,
Okay.
yes, yes. It's visible.
So today topic I'm going to cover it is the how the artificial intelligence is involving in the disease detection, classification, and biological sciences. See, I think you are already working with a lot of biological sciences. Maybe if you are expecting a lot of biological science in this session, maybe sorry for that, but I'm more into the AI engine. I will create it like how the models will be effective. What is the importance of the artificial intelligence? So, and how this artificial intelligence makes our life easy. So, those topics I'm covering more here. Along with that, to our projects also, I'm going to show you how I developed that project, on what are the innovations, how these projects also will be useful. So those things I will cover it here in this lecture. So first, let me go with the what is the agenda for this session. So first, I will give the what is the background for this artificial intelligence. and what is the natural intelligence and what is the artificial intelligence, how the data and historical patterns, the role in this artificial intelligence, what are the probabilities, what are the machine learning algorithms, and computer vision, natural language processing, and generative AI. So how these techniques we can use it and effectively we can grow our biological science. See, if we are using like in a conventional methodologies, the world is moving very fast towards the multidisciplinary areas. See, earlier I also did my PhD in the my master's in biological sciences, molecular biology I done in Sweden. Afterwards, I done my PhD in chemistry, so biosensors and bioelectronic. I have done a lot of research and with the ended with the several publications also. But what was my observation during my 14 years ago? I done my PhD. So by that time, what was my observation is like if I am using like a conventional methodology, there are like an error prone, trial and error based mechanisms I have to follow. So during that time, there was no much artificial intelligence, not much like intelligent applications. We cannot see it, but all the methodologies, protocols, procedures, laboratory work, human hectic, several experimentation, everything was doing like some of the concepts we are formulating, and we are trying to prove that whatever the formulations we have formulated, those one we want to prove it. So this was the work we are doing, but it takes like years and years for any of the conclusions. So now after that I understood like if we have working with the data, then it will be very good. So that is the reason completely I have started integrating this artificial intelligence into my projects. So so let's go here. What are the conventional methodologies? As I mentioned, the labor intensive work we have to do in a conventional methodologies if we are following, and time consuming and error prone, skill set of the, maybe in this medical field I'm talking here, the skill set of the technicians are different, person to person skill sets is different, and we need like an extensive machinery, extensive tools, and experimental procedures we have to follow. And of course there is no predictive analytics we cannot do. So whatever the experiment we are doing, we are getting the results, those results we are interpreting with our outcome. So this is what some of the conventional methodologies we follow. But here, when we observe in the market, in the how the business is shifting over the period. So before going to that, how this artificial intelligence will be used, how the artificial intelligence will be effectively we can use it. But before, we can ask some questions here. Okay, maybe if I am asking a question here, world's biggest taxi company, which is the world's biggest taxi company, and how many taxis and drivers are needed to start a world's biggest taxi company. And if I am asking the next question is like in a world's biggest restaurant chain, I want to make it. So how many kitchens I needed, how many chefs are needed, and the same way the media company, how many journalists I needed, as well the biggest hospital also I want to make it in the biological field. So how many doctors I needed to hire here. So this is the question first, it will get it. When I'm starting my business, any of the business in this area, first I'll ask myself. Maybe if I ask this question in 2000, 2000, early 2000, or maybe early 1999, so the answer was clear. How many taxis you needed? Maybe a million taxis I needed, a million of the drivers also needed, maybe millions of kitchens is needed, chefs also needed, like that. There was like in 1999s or maybe early 2000, we were working this kind of model, this kind of business models we are working. See, when we are working with these taxi companies, we'll take like one example here, how the old business models were running, how the AI is shifting these business models, that we will discuss here. First, we'll go with the how the old business models are working. See, for example, a taxi company. In earlier days, there is a customer here, there is a customer here, he is looking for a service. There is a taxi, he is looking for a business. Okay, maybe customer is moving this direction and taxi also moving this direction. Definitely they will meet and they will get the business. So customer will get the service, taxi is also getting the business. So then there is everyone will be happy. And the second scenario, the customer is running, sorry, customer is waiting, and taxi is coming towards his direction. So definitely this time also, this scenario also happy. The third scenario, the customer is going towards the taxi, and the taxi is getting like in a business, and the customer also getting the service. In this scenario also, you will be happy. And another scenario also, maybe the customer is going very fast, and the taxi is moving very slow. In this case also, the customer will be happy, and the business will be happy. But what is the drawback here in this business model? What is the drawback? For example, let's assume here customer is moving other direction to find the taxi. Taxi is also finding moving other direction, opposite direction to find the customer. In this case, there is no success. Other scenario, maybe customer is moving downwards, taxi is moving upwards. In this case also, business will never work. Maybe if you think like in here, the customer is walking this direction, taxi is another direction, then in this case also you cannot find it. Maybe customer is moving the different directions. There is a probability, because if the customer wants to find the taxi, or maybe taxi wants to find the business, there are like in a lot of areas, they're like in a doing like in a trial and error. Maybe they are moving randomly some directions. If they are fortunate, they are finding, otherwise they are losing the business. So if I see like in probabilities, what is the success probability here? What is the success probability here? Four options we have, like a customer can go into the 360 degrees, car taxi also can go to the 360 degrees. Total is like an options are 720 options we have. In this four options, the customer and the business will get success. So that is like in a success chances is only half percent, only the success chances. What is the failure chances? There is like a huge failure chances we have. So this is the drawback in our old business models. Now you understand like how the business models are facing the issues earlier days. Now it comes like what is the solution? Why these failures are happening? Lack of information. There is no data. That is the reason that the customer doesn't know like in which direction taxi is moving. The same way taxi also. So this is the problem. Now how this overcome this problem, and how the data driven applications will be solve this problem. For example, now the new business model I'm going to explain. Here again, the customer as well as the business we have. Now what the customer will do? Customer will send the request. There is like algorithms are there. AI algorithms, or maybe data center, data information. Because here this data center information, they know where is the exact customer details. We can find it through these models, through this data, through this request. We can identify where is the customer is located. The same information we are passing to the business. Where is this customer information? Then they are connecting with this connection. So in this case, exactly there is no error. Exactly the customer location identification, taxi location is also identification, and they are getting like in a business connection also they are doing. So this is the way nowadays the businesses are moving. This is like in a more effective business. So how this one is coming here? Because of the data driven model. Because we have the data, that is the reason AI models are able to connect, able to coordinate with the customer, with the taxi, with the customer center. Then this business is successfully running. So now we can ask like in a previous slide, we can ask like in a business shift problems. Yes, these are the questions we were asking, like in a world's biggest taxi company, how many taxis and drivers are needed? My answer is zero. How? Because nowadays zero taxis I needed. Why? Because how the Uber and how the Ola is working. Have ever they have like in any taxis? No taxis, no drivers. They never hire the drivers. The next question is, how many kitchens, how many chefs are needed to start a world's biggest restaurant? Zero. I don't need any kitchen. I don't need any kitchens. I don't need any chefs. So how the Zomato and Uber, how the Zomato and yeah, other Swiggy is working? How many journalists I needed for starting a biggest media company? Zero. Because you can see the YouTube. YouTube never make any video. Who will make the YouTube content? We are creating. I am posting the YouTube, you are watching. You are posting the YouTube, I am watching. So LinkedIn, who is what are the posts are LinkedIn makes? LinkedIn never post. LinkedIn only the mediation company. They will take it, your input, and they will give to the other people's view. The same way the Facebook and everything. So there are no journalists also not needed. This is the shift is happening. Then now question also, if I want to start a world's biggest hospital, how many doctors I needed? Of course, this one also zero doctors. Sorry, if any doctors or maybe anyone is here, excuse this my answer here. But of course, nowadays immediately it is not coming. But in upcoming days, definitely, uh, this is the reality will come. So there is no need to maintain any doctors. If I have like an AI consultation apps and virtual doctors, if I have virtual consultation with that, I can solve these problems. So this is like, you have to understand how the data is shifting, how the business is shifting from our conventional methodologies to the advanced AI applications. And you can also understand that importance of the data here, because how these are all this are happening because of the data. If you have the data, you can able to do any kind of businesses nowadays. See, earlier days they were saying like, if you have like in a country having with the oil, you are the richest country. But now this completely change. What is the now it is changed? If you have like a highest large amount of data, if you correctly understand the data patterns, then you are the richest person. So that proverb also changed here. Now let's go here with the what is the algorithm, what is the machine learning algorithm. We'll understand like some of the concepts, then we can go into the deep dive. So what is the algorithm and what is the machine learning algorithm? For example, you can see here, what is the algorithm? Maybe you are writing a small piece of code, any code, that is an algorithm. Now I have written like in a here, A is equal to 10, B is equal to 15. What is the result? Of course, this is my algorithm. So this is input. I pass to my logic. I have written like this is A plus B is my logic here. And here I apply logic and I'm getting like an output. This is the normal algorithm. Then how the machine learning algorithm different from the normal algorithm? See, the machine learning algorithm, the word is giving like missions are learning. Have ever missions will learn? What is the mission? Mission made up of iron, plastic. But how the mission will learn? Where is the brain for the mission? So a mission is like how the mission will think. So that we have to think in our mind. First, we have to ask ourselves. It is like an algorithm we know, but how the machine learning algorithm works, I'll show you here. See, for example, 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6, 4 plus 4, 8. And okay, now if I ask like, what is the answer for the 6 plus 6? There is no doubt. Everyone knows this answer, 12. Now the machine learning algorithm here comes here. What is the 6 plus 6? This is the machine learning algorithm, right side. If I ask this question, answer is not 12. Definitely, answer is not 12. Why? Because if the machine learning algorithm, when this answer is giving, it will check the patterns in your data. Where is the data? See, for example, if I tell like 1 plus 1 is equal to 11, 2 plus 2 is equal to 12, 22, 3 plus 3 is equal to 33, 4 plus 4 is equal to 44, 5 plus 5 is equal to 55. Now, what is the answer for this 6 plus 6? 66. Not like 12 here. Maybe here answer will be 12. This normal algorithm will tell like answer 6 plus 6 is 12, irrespective of the previous pattern. But the machine learning algorithm is gives like 66 because you can see the data pattern. It is following some pattern. That is the reason it will give like 66. So this is the significant difference. What machine learning algorithm will do? Machine learning algorithm learn from the patterns. Here, there is like a pattern is there. It will learn from the pattern and it will give the prediction. 66 will be the answer. But here, this normal algorithm, this is the straightforward rule. Maybe you are writing like a straightforward rule, it will give this one. So here, the pattern based it will give. For example, in your YouTube, I think you all experienced this scenario. In your YouTube, you are watching some video Next day, when you open the YouTube, without searching such videos, automatical recommendations are coming to you. Who is giving that recommendations to you? Is there anyone is sitting in YouTube office and they are recommending to you? No, because whatever the you done in a previously, whatever the data patterns you have followed, that patterns are machine learning algorithm. In your YouTube, there is a machine learning algorithm is there. That algorithm, the powerful algorithm is there. That algorithm is learning the patterns. Based on these patterns, the output is coming. Similarly, if you are treating the patient, if you have like a historic data in a biological science, maybe when you are disease detection, if you have a lot of symptoms you have, that lot of symptoms, if you can train to your algorithm can able to understand it from that patterns, and it can give like in a future predictions. So that is the advantage with the machine learning algorithms here. This is not like in a rule based here. Okay, now let's go to the you understood like what is the algorithm versus machine learning algorithm. Now we will go with the natural intelligence versus artificial intelligence. See, in natural intelligence, you can consider a doctor or maybe a scientist, whoever you think, that is the natural intelligence. How this natural intelligence will come here? By born. After that, he is taking like reading the textbooks, articles, symptoms. He's several use cases is treating through the experience and from the university education, biochemical values, metabolism, life cycle. He's understanding everything, and he is getting like a natural intelligence. He's getting, and some of the adaptive intelligence also is getting. This is the way everyone will get like a natural intelligence. Now, natural intelligence, if a customer is coming to you, to the doctor, what a doctor will do? Doctor will understand what is the customer details, maybe the customer age, customer BP, customer cholesterol level, customer, all the values he will collect it. Then he will give the what is the disease that patient having. That is the detection it will be given here. So here the present result, in a present, what is the patient having. But doctor can estimate it next to 3 days, next to 4 days, what will be happen with these symptoms. That he can predict it. But he cannot predict it what will happen in the next 1 year, next to after 5 years. Because of this today disease, what will be the cases after 10 years. That some, if doctor's skill set is good, then he can also able to do that one. But there is no particular education or maybe particular knowledge that having like in a future 10 years what will happen, that information is not there. Okay, let's take like here he is today he is detecting the diseases present day with the past data and his previous experience. He is able to classify it the similar way, but in the future predictions he cannot do it. Now let's go with the how the doctor's efficiency. For example, you can see this is the university. From this university, there are like hundreds doctors are graduated. Will you believe all these 100 doctors are same skill set they have? No, maybe one doctor is very good, one doctor is worst. One doctor is like big cardiologist, other doctor is like a normal doctor. That means all are studying from the same university, even though there is a accuracy is matter. There is like in the natural intelligence how they is adapting. They are not maintaining like all are not same. So that means we have like some of the drawback here. Maybe if you are visiting to the good doctor, maybe you are lucky. If you are not unlucky, then there is like some of the issues also may raise. This is the current business problem. Now let's go here. In a what is the consistency? Okay, doctor is here. There are like different patients are coming to this doctor. Maybe the first he is very fresh mind, the doctor. He is able to process this data. What is the medical report, and he will detect it. He is getting like a second patient, third patient, fourth patient. Will he do the same energy levels from this patient to this patient? Maybe when the first patient is processing, he's like in a fresh mind, he can do it. But when the thousands of patients data they have, maybe after processing the 10 patients data, then accuracy may go down. That is like, it depends on the doctor mood, doctor behavior. With that load of the doctor, it will take like the consistency also will get the question. The first is here. Okay, so all the doctors are not the same accurate. Second one is like within that one doctor also, if you are considering, there is like problem with this consistency. To how to solve this problem? Maybe if I have like an artificial intelligence, if I create it, then I can solve these problems. How the natural intelligence is coming here? Sorry, here he is getting the knowledge from the sources. Maybe these are the sources. In his lifetime, he's spending like 4 years in the MBBS, 5 years in the MBBS degree. Then he's understanding everything and he is getting the knowledge. Similarly, what I do here in my artificial intelligence, maybe this is my artificial intelligence model. What I will do, this is the robotic doctor. You can see how the robots are doing this operation. But here I'm creating like I'm creating like an intelligence to my systems. How? Because there is like a data patterns I will show. Maybe how the COVID patient, how the human normal healthy patient symptoms I will pass to my algorithm. My algorithm will understand how the healthy patient will behave, how the um, COVID patient will behave, and what are the behaviors, what are the correlation between them, and the features correlations also we do this one. Some of the images also I will pass. Maybe the image patterns also can be understand through these models, video patterns, text tokens, audio patterns. There is like because this is the all this information I'm using to train my algorithm. This is the artificially I'm creating to this intelligence here to these systems. My model here, my algorithms are here. It is understanding here from the patterns here. Then my algorithms are becoming like perfect. How we are training our doctors, the similar way I'm also training here with my models here. The difference is only here. I'm using like models to train it. After that, artificial intelligence systems will come. Then the questions also, the same questions we will also ask again. How these artificial intelligence models are accurate. Maybe in my laboratory, this is my AI lab. For example, let's consider this is my AI lab. In this AI lab, I have trained one algorithm. The same algorithm I copy pasted several times. How the university is graduating like 100 students. Here, I'm also preparing like 100 algorithms. Is 100 algorithms also following the same accuracy? Yes, ideally, because I'm using the algorithm, I'm using the patterns, I'm using the same patterns. So then my algorithms also will be learned the same similar way. Maybe the slightly 1 to 2% error might be there, but more or less all algorithms will be the same. But you cannot give the guarantee that from the same university, 100 doctors are coming, they are not all the same. This like an accuracy matters here. So I can solve one of the problem with this accuracy. Next question, you will also ask like if I have like thousands patients I have here, so my model will never get like tied. Maybe if you are sending like one patient details, or maybe 1,000 patient details, or maybe 10,000 patient details, processing will be the same. Depends on the data patterns, the processing will be the same. Then the same consistency also I can give that like uh, my model is like more consistent towards the any of the records. Maybe today I got like millions of patients records, I got it within a fraction of times. It will do like correct predictions without showing much errors. The consistency also it will maintain. So this is the advantages with these artificial intelligence models. And what are the other advantages? I don't need to spend like 5 years in the MBBS degree. I can train my algorithm within hours in my laboratory. Maybe a doctor can come here with his 16 years education. Sorry, I'm not anything talking about the negative to the doctors. Just I'm telling like how the, because of course this is like an unethical I'm talking, but this is like in a science I'm talking here. Okay, how the world is moving towards the technology. I'm talking about that. Okay, here you can see with this model preparation, maybe if I have the correct data, I can build it within a fraction of hours, maybe minutes also I can build my models. So it's like in a time less consuming. Maybe we don't need to spend like in a 5 years there, even though after 5 years there is no guarantee for that probabilities we can check it. So these kind of things, all the problems can be solved here. Okay, next, if the data science will come, how the data science will work here. Data science is nothing but like an artificial intelligence we are talking. We are processing the data. In this data, we are making like an extracting these patterns. Then we will see like how the predictions will come here. For example, you can see here the first important is like any data science problem. We need like a data. If you want to predict, if you want to identify the disease detection, disease classification, disease prediction, the first doctor will ask like what is your symptoms. But here in our case, we are checking like what is your data, what is that data organization. Okay, maybe some biochemical data, maybe pathological data, or maybe some physical data, environmental data. We are collecting everything, and after that we are starting with the analysis of this data. By doing this analysis, maybe the same data we are doing like in visualizations, and also patterns we are identifying through the statistics, descriptive statistics, some of the probabilities theorems we are applying, how to understand this data. Those things we are analyzing here. After that, we are making the inferences. Then we are building some machine learning models here. These models either may be regression models, or maybe a classification models, or maybe a tree-based algorithms. There are different algorithms we can build it, because these algorithms can give exact predictions how the algorithm will be classifying the given input. After that, there is like ensemble methods also there. There is a bagging methodology, boosting algorithms also we can apply. If you are not believing this AI algorithm, in a one time you can run like several times with the different data sampling. So those algorithms also we can build it to find it our fine tuning our algorithms. And there is like a more advanced algorithms also, deep neural networks also we can apply. There is like an artificial neural networks we can create it, convolutional neural networks we can create it, RNN, recurrent neural networks also we can create it. What are the differences? The artificial neural networks is like a conventional methodologies, conventional algorithms, but here it will give like more layers, and it will give like an improved accuracy it will come. When you are working with the image data, video data, audio data, then we apply the convolutional neural network to make it. The recurrent neural networks, it will give like a short term, maybe when you are working with the time series data, maybe the sequential data, maybe 1 minute the cancer is increasing. The next 1 minute, what will be the happening? How that disease is progression. If you want to understand that one, it will give like a forecasting. Maybe if this disease is spreading like this, the next 1 hour, what will be happening? Next 1 month, what is the output? Next 1 year, what will be the scenario? Like that, we can do the predictions through this recurrent neural networks also. So there is a natural language process. If you have like all the medical reports, all the text tokens, we can process it, and we can do with this NLP techniques. Generative AI, you can generate the scenarios through the previous patterns. Maybe there is like 100 types of symptoms you have for the a disease. So you can pass it to the models. You can generate it like how the new patterns, or maybe how the future predictions will come. That is through the generative AI also we can do it. There is like several architectures nowadays. You are hearing like GPTs, Chat GPTs, Gemini, and Perplexity AI. There are different algorithms are coming here nowadays. Several applications are coming. So encoder decoder architecture is there. By using that one, we can do it. So there is like people thinks like these are everyone is using like in a different industries, banking sector, health sector, because every sector the backbone will work same. Okay, and finally, you can go with the several validations, and you can also see the confusion matrix, how the accuracy you can calculate it. The same way you can deploy in the front end applications, mobile applications, and software skills you can build it here. So this is like an entire thing will come like an overview of the data science. Uh, okay, next we'll go to the sorry. Okay, here this is the typical data science life cycle. How to do the predictions. So there is like in a first you need to collect the data for any disease. If you want to detect it, first to collect the data. After collecting the data, you can perform it like an exploratory data analysis. You have to check how the data is distributed, what is the statistical distribution, what is the categorical distribution, how the inferences are running, what are the probabilities, and what is the relationship between the one variable to other variable. For example, if it is like there is like what is the relationship between the cholesterol versus heart attack? If cholesterol increases, what will be the chances? And if the BP is decreasing, what will be the other complication? That relationship you have to clearly understand it through this EDA. After that, which are the important features for your model? You can select those features. Then you can go with the data preparation, input and output definition. You have to make it. Then you have to load your models, AI models, train that algorithms. Because if you are having this data, then you can start it to train the models. Once the models got trained, you can go for the validations. Validations, successful validation is having, then you can deploy these models in the production. These production, it will go to the real-time predictions we can go. This is a typical data science problem, a typical data science life cycle. We have to follow these steps. Now, I will show you one of the algorithm, how I detected the cancer detection. Okay, here I'm showing like in one of my project here. It's like in a previous project. Uh, this is like in a machine learning algorithms I'm showing here. So in the machine learning algorithms, as I mentioned here, uh, here I mention is there is like a regression algorithms are there, classification algorithms are there, some of the tree-based algorithms are there. So some algorithms works on the hyperplane based. Some algorithms works on the distance based theorems. So Pythagoras theorem based algorithms we have like there is like in a backend is working that one, and some of the hyperplane based, support vector machine based, some of the probability based. Of course, the probability based algorithms are tree based algorithms, as well as the logistic regressions and naive based algorithm. These are the probability based. Probabilities algorithms are very powerful, but first we'll go with this k nearest neighbor algorithms based cancer detection, how I did here in the project. I'll show that one. So how the this is the theory. Okay, what is this Pythagoras theorem? I think sorry, I haven't shown that one here, but if I can show here a pen here in the dimensional space. Oh, it's not coming. Just a minute, guys. Sorry. Okay, pen here. Okay, so in the dimensional space, if you want to find it, where is the what is the distance from here to here? So if I want to find it like in this distance, first what I will do, what is the x-axis difference to calculate that one? First I will find it like what is the x-axis difference and what is the y-axis difference. If I formulate this one, x-axis versus y-axis, then I can find it like here in the dimensional spaces I can find it. So for example, this is like just imagine this is a malignant cancer. This one is like a benign cancer attributes. Now I'm finding like because first I train my algorithm, I will place my algorithm. If any kind of new class is coming, my algorithm can able to detect it. It will correlate with the previous data, and it will check like what is the distances from these data points. Then it will classify it in the finding the nearest neighbor. Where is the nearest neighbor? Those things it will predict it. So that is the way it will work here. And the cancer detection algorithms, see first as a first step, I collected my data here. Okay, this is the data. What is the data I am having? Approximately 600 rows I have. That means 600 patients records I took it. and 33 columns I took it here. These data I have checked with like how many classes having like a malignant and how many are the benign classes. I understood here 65% of the data with the benign cancer and malignant cancer is like remaining of the 35% of the data with the benign cancer. So then I have understood like what is the relationship between these 33 features. What is the relationship between the radius of the mean versus uh, uh, another radiation of the concatenative. So these relationship first I identified. With this identification, I have selected important features from my for my project. So here I took it like an important features. After that, I started with the this is my machine learning algorithm. This is the algorithm I am keeping. This is nothing but like an KNN algorithm. So here I have started training my algorithm. If you can see it like in here, different experimentations I have done. So with this experimentation, I am identifying like an optimized parameters for my model. I am teaching everything to my algorithm, how the benign cancer look likes, how the malignant cancer look likes. Now, after finishing of this model, my algorithm knows how this benign cancer will patient will be look likes and how the malignant cancer behavior look likes. Then I'm also cross validation whether my model is correctly able to do it or not. Then I have applied the confusion matrix, how many times mistakes are coming here. These things also I have checked. Maybe if you are seeing here, there is like a true positives and true negatives are correct. There is no false positives. That means my model is showing like a 97% accurate. This is the result I got it. So here, this is the I have written entire coding with the Python. Then in a real-time predictions, how the real-time predictions happening? Because once my model is trained, this is my I have deployed this model in the laboratory. When the patient is giving the laboratory report, the laboratory reports are coming. These laboratory reports, instead of going to the doctor, I'm passing to my algorithm here. Instead of visiting my doctor here, I'm directly visiting to my I'm passing this one to the my algorithm. My algorithm have the it is having like an information here. How the maybe because of these records, it will identify and it will detect it whether that person is a cancer identification. It will be done, and what is the classification, whether it is a malignant cancer or maybe benign cancer, and what is the probability. It will also give like a probability also. Maybe there is a chances of 70% of the chance having like a malignant. Maybe there is like a 30% features also showing like a benign. But here the probability is like 70% is the highest probability. So then I'm detecting, I'm classifying this disease is a this patient is like a malignant cancer. Like that, if I'm in a real time in a laboratory, in a laboratory, maybe in a day, every day, 10,000 patients are coming to this laboratory. I don't need to send like 10,000 reports to the 10,000 doctors here. I can pass only one my model here. My model is also not ask any money for doing this duty. So then immediately it will process and it will give the result. So this is the way one of the business problems we solved here in the um, uh, real time. Maybe there is another problem also I will show you. Computer vision AI models also I'll show you how the architecture is there. For example, there is a MRI scan. The patient is lying down in the MRI scan. This is like an MRI image. This is the MRI image. Maybe with this image, doctor will identify whether patient is a which type of tumor he has. Maybe the glioma tumor, or maybe what type of tumor the patient have. That we can see it. But here, when the MRI scan images are coming, first I am building my model. So this image as it is, I'm doing like an image pre-processing, image reshaping, several processing steps I'm applying here, image binarization. I'm cleaning this image. After the cleaning image, I'm doing like an image annotations and bounding boxes I'm keeping. For example, here is like a small tumor here, for example. So then this information I'm bounding boxes. After that, I'm training my algorithm. Here is like my convolutional neural networks algorithms I built, and here these are the different models I am building. Then I'm training my algorithm. That means I'm telling, maybe there are like 1,000 images I take here, 1,000 images. These 1,000 images I'm training my algorithm here. After training the algorithm, I'm building like one front end application, because once my model is perfectly done, I'm building one front end application. Then I'm also building like a dashboard here. This dashboard information, whatever the outputs are coming, maybe today is like a patient one is coming, tomorrow patient two will come, patient three will come. So all the patient records also I'm storing here in the my databases. This is the general architecture I'm showing here. And what is the data set I have used? I have used the data set for my training purpose. I got like an approximately, you can see these are the tumor classes. Maybe a patient have like a pituitary tumor, meningioma tumor, glioma tumor, and there is no tumor. This is like a healthy patient. Like this, I have taken like this many numbers here, MRI images. Then I started splitting my data, train, test, and validation. Because why I'm taking like this one, this information I'm going to train my algorithm, this information and this one. Finally, I will validate it whether 90%, 95% accuracy if I want to know it. Once my algorithm is done, I'm going to test my algorithm here. Like that, this is the way I have created. Now you can see the tumor class. Uh, Tumor class, there are different tumor classes I took it. Number of images I took it. Approximately more than 1,000 images I took it, and I have tested the data also. So this is the just only the statistics of how my training, testing, and validation, and the class distribution also I'm showing here. Okay, so this is like a meningioma tumor, and this is like a glioma tumor, and a pituitary and a tumor. So then these are the different types of images we have, and we train the algorithm. Algorithm is showing like a very good accuracy. Now, what is the use? Okay, maybe what are the tools and technologies I use? Python I use like in a tools and technologies. The Python servers, TensorFlow framework for my building the machine learning algorithms, OpenCV for the image processing. So environment code development I use this one, and also some of the libraries also I use. And this one is like in a PyTorch also I use. So these are the different experimentation setups also I have done. Now, during this model training procedure, I am observing how my model is learning. There is like, what is the accuracy is coming here. And you can see initially my model is 40% only the accurate. But while I'm going like in a training by training, epoch by epoch, if I'm increasing this training time, my model is like in a 97% is increase. Just you can imagine, maybe doctor is like in first year, he is able to detect it like in a 40%. In a second year, when it comes to the second year, he increases like in a 60%. Like that, we will see like in how the doctor is learning the same way, how the model is also learning. I'm observing here. But here, years it will take, but here it is take like in hours. Hours or maybe days. So this is the validation protocol also I have applied, because in future, if anyone asks like how the model is accurate, this is the evidence for my model validations. So there is like a model is also pituitary type of models. It will be 93% perfectly it is identifying, and meningioma tumor type 78, and this one. So once this model is learned, my overall performance is like my model is approximately 90% is the accuracy. So what is the use of this model? So here, in once this model is ready, I am keeping this model here. Whenever the patient is coming here, directly I'm sending this patient image to my model, or maybe this model is like in your mobile phone also. For example, let's you can consider like this is like a mobile app. In your mobile app, you have this model. When the patient report is coming, directly you can send like your mobile app. Your mobile app will tell which type of disease it is, which type of tumor it is. This is like a real-time applications are running in the hospitals also, but it is in a starting stage, but it is the rapidly developing these applications. So, uh, sorry, what is the time? I am not seeing the time. Is it okay, sir?
Wow.
Another 10
Yeah,
minutes?
Yes, yes, you can take another 10 minutes. You have 9 minutes as per schedule, but you can take, sir.
Thank you, sir. Thank you so much. And okay, what is the generative AI? Maybe I'll also explain like how the generative AI also will work. Nowadays, you are hearing like in a generative AI. There is like in a lot of techniques are coming. Chat GPT, Gemini. Maybe these are like in a companies are developing. That is like in a tools. But how the back end, how the real time, if you want to develop it, your generative AI for your use cases to find it like in a particular disease you want to make it, then you have to give like in a training. But the training data, how it will come? Just I will give a small analogy because you will easily interpret here. See, for example, there is a original note we have here. This is the original note we have. He's like a thief. Okay, imagine this is a thief. Okay, he is generating by seeing this original note. He is generating the fake note. This is the fake note. This fake note, this is the synthetically fake note he's creating. He is sending to the policeman or maybe bank officer. Bank officer knows this is a synthetic note. Then what he will do? Immediately he will tell note is fake. Better luck next time. This is the information he's telling. This information it will go to the thief again. What is the usage for him here now? Because thief will understand already I created one fake note. Policeman detected. So policeman is telling how he will detect it. So that means the original notice look like this, fake notice this one. So this is the information is passing to the thief. What thief will do second time, he will make another synthetic note with the improvement. He will make like a more improvement he do, and he will generate like a more synthetic note. Good to it will match to the original note. He will generate it. Policeman also knows that thief is coming with the another synthetic note. So then policeman also cleanly observe, deeply observe what is the difference from the original to synthetic. Then he will identify and he will tell like this is also a fake note. So this process will continue. Maybe the policeman is throwing the note because this is a fake and he's telling why how he identified. Maybe the right side corner is not correctly match here. Then he's throwing. Then what the thief is doing? Okay, right side corner he's correcting and he's sending again. If this iteration is going continuously, uh, simultaneously, thief is also learning how to make the good note. Police also learning how to identify the fake note. That means thief is teaching to the uh, policeman. Policeman is teaching to the thief. After several teachings, policeman also will be perfect, and thief also will be perfect. If thief is perfecting, what is the use? The thief will generate like a more good notes. That is the application. So here also in our so here you can see thief and policemen are exchanging their informations. Because of this exchanging information, he is also perfecting. He is also becoming perfecting. Now let's take like here uh, at the end, he is able to generate match to the original note. Of course, he is also can able to maybe he can now first time he generate like a 40% matching. So now to the original note. Now he become like a 99% he is perfect. So there is like an he is generating, he is like a generator, he is like a discriminator. He is like a discriminating the note. That means generator also improving the knowledge. It is trying to make more generation. Also discriminator also will also help to this information. That means he is like an agent, we can call it. The agent is detecting and he is making like an helping to the generate the more relevant information. So this process will be continued and it will be generate like an images, videos, text and lot of things it will be come here. So with this, what is the biological side applications we did? I did. Sorry here. So this is the generative. Oh, I don't. Okay, why I use like in generative images? There is uh, a generative adversarial neural networks are there. Why I will use here? For example, there is a rare disease is there. Rare disease. maybe this rare disease, I have only the 5 images only. I have 5 images only. I have for the rare disease. Now I want to build my AI algorithm. With these 5 images, I cannot build my AI algorithm. I cannot do it because AI algorithm needs more data. So that is the reason what I'll do. If I ask here to the laboratory, maybe I need to pass like if I want to get like 1,000 images, I need to request the doctors. I need to take the several signatures, several permissions. I need to take it. The government policies also have to follow. There is like a lot of things I need to do it to get my data. What I'll do, and every time if I want to get the data also, I need to spend like an MRI or maybe whatever the scans we have. Through that MRI, I have to spend like for each patient also. It will be like in a cost effective also. But instead of doing that, if I have like only 5 images, with these 5 images, initially my images I started like in a training my algorithm. My initially my algorithm is not good to make the synthetic to match with the original fake image, original images. But if I continue this process, now you can see this is like an improved. After that, if I'm continuing like this, the improvement is happening. At the end, okay, sorry, I come like last. At the end, I got like an a here. There is like an a perfectly matching this images. I can generate it. So like that, the generative AI also can be help to making the several biological problems, maybe the gene sequences if you want to do it, and the patterns you can also identify easily. The machine learning algorithms are more powerful nowadays. It's like if you can use it your more data, then of course the learning process will be done, and accuracy also will increase. So if you are continuously adapting the technologies, latest technologies, whatever the world is moving towards that direction, if you are learning, definitely you will be perfect. So there is like an earlier also companies, some companies we know that we have seen like some conventional methodologies if they are using, they're out of the market. I think in 1995 and 99, there is like a Nokia phone was like very popular in India. Yes, not only in India, worldwide like it's like a very popular. They haven't upgraded their softwares. They haven't upgraded their technology. They are still looking like because they are like in a top in the market, but they never thought of to upgrading their skills. In the smartphones, once the smartphone comes, then it is out of from the market. So understand the skills upgradation and try to upgrade your skill sets and match to the current problems, then you will be survived in this market, and you will be also be perfect in the uh, make like more innovations and more intelligence applications. You can build it that can serve to the people. That is like in a better, so it will come. Definitely you will get like in a success also. And thank you so much for your attention here. And if you have any questions, yes, I'm open to.
Thank you very much, sir.